Question 1. When analyzing a retrofit plan for an aging R22 system, technician Mr. Solis is tasked with converting the system to a hydrofluoroalkyl HFO refrigerant. The existing POA was recently flushed and replaced, and system seals were replaced. However, upon system startup, erratic compressor operation and high discharge pressures were observed. Which of the following is the most likely reason for these issues? A. The expansion device was not recalibrated to match the new refrigerant characteristics. B. The suction line was undersized to HFO refrigerant's lower density. C. The compressor motor windings were incompatible with HFO refrigerant. D. The POA has low miscibility with HFO refrigerants. Answer. Correct answer. A. Explanation. HFO refrigerants often have different thermodynamic properties than R22, especially in terms of pressure-temperature relationships. If the expansion device TSB was not adjusted or replaced to suit the flow characteristics of the new refrigerant, it can lead to incorrect superheat control, causing compressor flooding or high discharge pressures. POA is generally compatible with HVACR and suction lines. Impact efficiency more than safety. Refer to RE Guideline N and EPA Section 608 Retrofit Best Practices. Question 2. In the context of selecting a properly sized rooftop unit for a retrofit in a 4,000 sq ft office space, what is the most appropriate course of action if the original system was significantly oversized for its actual load? A. Upsize the new system to accommodate future building additions. B. Match the new system size to the original system to avoid performance uncertainty. C. Perform a manual J and S calculation to right-size the new unit based on current usage. D. Reduce size slightly but maintain a margin for error. Answer. Correct answer. C. Explanation. Manual J residential and manual S equipment selection or commercial equivalents should always guide equipment sizing during retrofits. Oversized systems can short cycle, reducing efficiency, dehumidification, and equipment life. Relying on old sizing can perpetuate inefficiencies. Right sizing using current load data is required under HVACR guidelines and ASHRAE 183 for energy efficiency compliance and equipment longevity. Question 3. From a practical standpoint, what is the best approach when retrofitting a ducted HVACR system where the existing return duct is undersized and causing high static pressure issues? A. Add a booster fan at the end of the return duct to increase airflow. B. Convert the return to flex duct to allow easier routing. C. Increase return duct diameter and add more returns to reduce resistance. D. Install a higher static pressure-rated blower motor. Answer. Correct answer. C. Explanation. High static pressure from undersized return ducts restricts airflow and stresses components. Increasing return duct area or adding additional returns reduces pressure drop and improves system efficiency. Adding a booster fan can create turbulence or noise. Flex ducts often increase resistance. A stronger blower doesn't resolve the root issue and increases energy consumption. Refer to CAR Manual D and ASHRAE 62.2. Question 4. The most significant aspect of a vapor compression refrigeration retrofit is maintaining the balance of which two pressures to ensure system performance? A. Ambient and evaporator pressures. B. Suction and discharge pressures. C. Condenser inlet and evaporator outlet pressures. D. Compressor head and atmospheric pressures. Answer. Correct answer. B. Explanation. Balancing suction and discharge pressures is critical in maintaining system efficiency and compressor longevity. If discharge pressure is too high or suction too low, it results in excessive energy use and possible compressor damage. Suction pressure directly affects evaporator performance and discharge pressure affects condenser operation. These pressures are central to any system retrofit. Refer to ASHRAE Handbook. Refrig. Chapter on System Practices. Question 5. Given the circumstances, technician Avery is proposing a retrofit to replace a 20-year-old furnace with a dual-stage heat pump system. The customer is concerned about cost and skeptical of heat pump efficiency in cold climates. What is the most effective response to address the customer's concern? A. Emphasize that modern heat pumps work efficiently even at -20 degrees. B. Suggest sticking with furnace since it has been reliable. C. Explain the benefits of hybrid system with gas backup and provide performance data. D. Dismiss concerns and highlight potential rebates. Answer. Correct answer. C. Explanation. Modern dual-stage heat pumps perform well in cold climates, but combining them with gas backup, hybrid systems alleviates performance concerns in extreme weather. Providing data. E.g., COP at low temps builds trust. Rebates are helpful but not the primary concern here. Customer communication guidelines under CAN emphasize aligning solutions with customer concerns using evidence-based explanations. Question 6. To what degree does improper subcooling measurement affect performance during a retrofit startup? A. It slightly reduces compressor performance. B. It can lead to catastrophic compressor damage due to floodback. C. It only affects systems using capillary tubes. D. It has no measurable effect if superheat is correct. Answer. Correct answer. B. Explanation. Incorrect subcooling can result in liquid refrigerant entering the compressor, causing damage. Phenomena known as floodback. Even if superheat is correct, subcooling must be within manufacturer specifications to ensure complete condensation. Subcooling is critical in retrofits, particularly with new refrigerants with different condensing properties. Refer to EPA Section 608 and ARCE's Retrofit Guidelines. Question 7. As illustrated by retrofit best practices, why is replacing aged insulation on refrigerant lines important when converting from R22 to R454? A. Aged insulation may chemically react with the new refrigerant. B. Old insulation contributes to increased system capacity. C. New refrigerants have different line temperature profiles, increasing condensation risk. D. It ensures compliance with ASHRAE 55 comfort standards. Answer. Correct answer. C. Explanation. R454 operates with different saturation temperatures than R22, often resulting in colder suction lines. If insulation is aged or missing, it can lead to condensation, increasing mold or corrosion risks. Proper insulation preserves thermal efficiency and avoids energy waste. There's no direct chemical interaction, but thermal characteristics require updated insulation. Refer to ASH 15 and 90.1. Question 8. In what ways can improper grounding during retrofit affect inverter-driven HVACR systems? A. It causes high-voltage arcs across contactors. B. It interferes with compressor oil return. C. It leads to harmonics and controller malfunction. D. It reduces the SEER rating by 2 points. Answer. Correct answer. C. Explanation. Inverter-driven systems are sensitive to electrical disturbances. Improper grounding can introduce harmonics that affect the operation of microprocessors, cause nuisance faults, or reduce lifespan of variable speed components. NEC Article 250 and manufacturer specifications provide grounding guidelines to protect both system and personnel. Arcing is more typical of overload conditions, not grounding issues. Question 9. Across different scenarios, why is pre-retrofit documentation e.g. photos, specs, baseline performance critical for HVAC retrofit projects? A. It speeds up EPA reporting for refrigerant recovery. B. It assists in warranty claims and customer disputes. C. It validates code compliance for ASME inspectors. D. It replaces the need for commissioning documentation. Answer. Correct answer. B. Explanation. Pre-retrofit documentation is vital for establishing a baseline and serves as evidence in case of customer dissatisfaction or future warranty disputes. It ensures transparency and supports post-retrofit performance comparisons. While helpful, it doesn't fulfill commissioning documentation or regulatory filings. Refer to CAS quality installation specification and SMACNA documentation practices. Question 10. While examining a retrofit for a commercial dehumidification system, the engineer determines that the latent load is higher than expected. What is the most effective strategy for addressing this using existing HVAC equipment? A. Increase air velocity to maximize evaporator surface exposure. B. Lower the evaporator coil temperature to enhance moisture removal. C. Open outdoor air dampers for more ventilation. D. Increase reheat coil operation to drive off moisture. Answer. Correct answer, B. Explanation. Lowering the evaporator coil temperature reduces as dew point, increasing moisture removal. However, this must be carefully managed to avoid freezing. Increasing velocity reduces contact time. More ventilation can worsen the load if outdoor air is humid. Reheat adds sensible load but doesn't remove latent heat. Psychrometric control is key in dehumidification design. Refer to ASHRAE 62.155. Question 11. Given the circumstances, Mr. Patel is retrofitting a system that uses an HFC refrigerant. During recovery, he notices a sudden spike in pressure inside the recovery cylinder. What is the safest and most code-compliant action Mr. Patel should take immediately? A. Vent the excess refrigerant to the atmosphere in a well-ventilated area. B. Stop recovery operations. Secure the cylinder and notify a supervisor per EPA section 608. C. Continue recovery but reduce the flow rate to lower pressure. D. Transfer refrigerant to another cylinder without inspection. Answer. Correct answer, B. Explanation. EPA section 608 mandates that refrigerant must never be vented intentionally. A pressure spike suggests possible overfill or overheating. Stopping operations and reporting ensures safety and compliance. Continuing or venting violates OSHA and EPA regulations and risks equipment damage and personal injury. Question 12. While diagnosing an HVACR system exhibiting low cooling capacity, technician Is Ramirez observes that the condenser fan motor runs slower than rated, yet voltage supply is normal. Which is the most probable cause and best next step? A. Replace the motor immediately. B. Check the capacitor for signs of failure and test it with a multimeter. C. Increase refrigerant charge to compensate for low airflow. D. Lubricate the motor bearings without further diagnostics. Answer. Correct answer, B. Explanation. A failing capacitor often causes motors to run slow despite normal voltage. Replacing or testing the capacitor is a safe and logical next step. Lubrication might help if bearings are faulty, but capacitor failure is a common cause. Increasing refrigerant without fixing airflow will worsen performance. Question 13. From a practical standpoint, during an energy audit for a retrofit in a commercial building, which factor most significantly contributes to the decision to install a demand-controlled ventilation system? A. Building age and envelope construction. B. High occupancy variability throughout the day. C. Type of HVAC equipment installed. D. Presence of geothermal heating and cooling. Answer. Correct answer, B. Explanation. Demand-controlled ventilation systems modulate outside air based on occupancy to optimize energy use. High and variable occupancy justifies such systems. Building age or equipment type affects retrofit feasibility but not the primary control strategy. Geothermal systems influence HVAC loads but not ventilation control directly. Question 14. Considering the evidence as to Huang uses a digital manifold to measure pressures on a system retrofit, he notes that the superheat value is abnormally high during normal load. Which of the following is the most likely explanation? A. Overcharge of refrigerant in the system. B. Expansion valve stuck open. C. Undercharged system or restricted refrigerant flow. D. Dirty condenser coil causing high head pressure. Answer. Correct answer, C. Explanation. High superheat usually indicates insufficient refrigerant at the evaporator coil caused by undercharge or blockages restricting flow. Overcharge lowers superheat, and a stuck-open valve also tends to reduce superheat. Dirty condensers affect discharge pressure but don't directly cause high superheat. Question 15. In the modern context of retrofitting an HVACR system integrating a programmable thermostat with zoning dampers is proposed, what is a critical consideration to ensure proper operation of the new system? A. Use only single-stage thermostats to avoid confusion. B. Ensure thermostats and zone dampers are compatible and wired according to manufacturer specs. C. Disable outdoor air sensors during installation to avoid false readings. D. Place all thermostats in direct sunlight for better signal strength. Answer. Correct answer, B. Explanation. Compatibility and correct wiring prevent operational conflicts, short circuits, or system lockouts. Multi-stage or programmable thermostats often require specific wiring schemes with zone dampers. Disabling outdoor air sensors reduces system efficiency, and placing thermostats in sunlight causes false temperature readings. Question 16. While evaluating a heat pump retrofit in a cold climate, Garcia notices frequent activation of the backup electric resistance heat. What is the most likely cause and recommended retrofit solution? A. Heat pump is oversized and cycling frequently. Replace with a smaller unit. B. Insufficient defrost controls causing frost accumulation on the outdoor coil. Upgrade to adaptive defrost controls. C. Low refrigerant charge leading to inadequate heating. Add a refrigerant. D. Improper thermostat placement causing premature backup heat activation. Relocate thermostat. Answer. Correct answer. B. Explanation. In cold climates, frost buildup reduces heat pump efficiency and triggers backup heat. Adaptive defrost control algorithms minimize unnecessary backup activation, improving energy efficiency. Oversizing affects cycling but less directly backup heat. Thermostat relocation may help but isn't primary, and refrigerant level alone doesn't cause defrost issues. Question 17. When performing brazing in a retrofit of copper refrigeration lines, what is the most important safety and quality control practice to prevent refrigerant contamination and ensure joint integrity? A. Use flux on all joints before brazing. B. Purge the line with dry nitrogen during brazing to prevent oxidation. C. Perform brazing without protective gloves to improve dexterity. D. Use water spray immediately after brazing to cool the joint rapidly. Answer. Correct answer. B. Explanation. Purging with dry nitrogen prevents oxidation inside the tubing, which can cause black soot, flux residue, and restrict refrigerant flow, compromising joint quality and longevity. Flux is not used in refrigeration brazing. Protective gloves ensure operator safety, and rapid cooling can cause joint cracking. Question 18. From the perspective of indoor air quality, why might retrofitting a system with an energy recovery ventilator ERV be preferable over an exhaust-only ventilation system in a humid climate? A. ERVs are cheaper to install. B. ERVs exchange both sensible and latent heat, reducing indoor humidity and energy cost. C. Exhaust-only systems eliminate outdoor pollutants better. D. ERVs require less maintenance. Answer. Correct answer. B. Explanation. ERVs transfer heat and moisture between incoming and outgoing air streams, improving humidity control and reducing cooling load, essential in humid climates. Exhaust-only systems can draw in unconditioned, humid air, raising indoor moisture levels and energy costs. Installation cost and maintenance vary widely. Question 19. During the commissioning phase of a retrofit project, ISTA notices that the system's measured airflow is below design specifications despite correct fan speed and duct configuration. What should be his next step? A. Assume the design airflow is excessive and accept low performance. B. Check for duct leaks, obstructions, or closed dampers in the system. C. Replace the fan motor with a higher horsepower model. D. Increase refrigerant charge to compensate for airflow loss. Answer. Correct answer. B. Explanation. Duct leaks, obstructions, or improperly set dampers are common causes of airflow loss. Identifying and correcting these maintains system efficiency and indoor comfort. Increasing refrigerant or replacing the fan without confirming root causes is inefficient and may cause damage. Question 20. To what extent does improving a building's envelope, e.g. sealing air leaks, adding insulation during an HVACR retrofit impact system sizing and energy efficiency? A. Minimal impact. The HVAC system capacity remains the same. B. It allows for significant downsizing of equipment and reduces energy use. C. It only affects heating loads, not cooling loads. D. It increases equipment sizing due to added insulation. Answer. Correct answer. B. Explanation. Improved envelope reduces heat gain loss, directly decreasing heating and cooling loads, allowing for right sizing equipment and significant energy savings. ASHRAE Standard 90.1 encourages building envelope improvements as a primary energy efficiency measure. It impacts both heating and cooling, contrary to C, and never increases capacity requirements. Question 21. In light of recent developments, Kim is installing a new variable speed compressor during a retrofit. During startup, he notices the compressor does not ramp up smoothly and occasionally trips on overload. What is the best explanation and corrective action? A. The compressor is incompatible with the existing power supply. Replace the power source. B. Incorrect wiring or missing soft start controls. Verify wiring and install recommended controls. C. Refrigerant charge is too low. Increase refrigerant to manufacturer specifications. D. The compressor motor windings are faulty. Replace the compressor. Answer. Correct answer. B. Explanation. Variable speed compressors often require specific soft start or variable frequency drives to ramp up properly. Incorrect wiring or missing controls can cause overload trips. Replacing power or the compressor without verifying wiring wastes time and money. Refrigerant charge affects performance but not startup ramp behavior. Refer to manufacturer's installation manual and NEC guidelines. Question 22. From the perspective of electrical troubleshooting, Lopez is measuring motor current with a clamp-on ammeter and notices a phase imbalance. Which of the following is the most likely cause? A. Proper motor operation. Minor imbalances are normal. B. A loose connection or damaged wiring in one phase. C. Overcharged refrigerant causing mechanical binding. D. Incorrect thermostat settings causing cycling. Answer. Correct answer. B. Explanation. Phase imbalance often results from wiring issues like loose connections, damaged cables, or bad contacts. This can lead to premature motor failure. Minor imbalances under normal conditions are usually below 5%, but higher readings require immediate attention. Refrigerant charge and thermostat settings do not cause electrical phase imbalances. Question 23. Taking into account the evidence during a retrofit of a hydronic heating system, Chen notices uneven heating across zones despite proper pump operation. What is the most likely cause? A. Incorrect pump sizing leading to insufficient flow. B. Air trapped in the system causing blockages in some zones. C. Use of incompatible piping materials. D. Oversized radiators creating imbalance. Answer. Correct answer. B. Explanation. Air trapped in hydronic loops restricts flow and causes uneven heating. Bleeding or purging air is a critical step. Post-retrofit, pump sizing affects overall flow but unlikely to cause localized issues. Material compatibility is a long-term concern but doesn't cause immediate imbalance. Oversized radiators affect comfort but not flow and balance. Question 24. Given the circumstances, technician is new and is recovering refrigerant from a system suspected of contamination. What is the best practice to ensure compliance with EPA regulations during this process? A. Vent the contaminated refrigerant to the atmosphere since it is unusable. B. Recover refrigerant into an approved recovery cylinder and properly dispose of contaminated refrigerant. C. Mix the contaminated refrigerant with clean refrigerant and reuse. D. Store the contaminated refrigerant indefinitely on site until regulations change. Answer. Correct answer. B. Explanation. EPA Section 608 prohibits venting refrigerants. Contaminated refrigerant must be recovered into DOP-approved cylinders and sent for proper disposal or reclamation. Mixing contaminated refrigerants can damage systems and is illegal. Indefinite storage is unsafe and violates environmental laws. Question 25. Which of the following best describes the impact of oversizing replacement equipment during a retrofit on system performance and efficiency? A. Oversizing improves comfort by quickly reaching set points. B. It causes short cycling, reduces dehumidification, and increases wear. C. Oversizing has no measurable impact if airflow is adequate. D. Oversizing is necessary to compensate for older ductwork. Answer. Correct answer. B. Explanation. Oversized equipment short cycles frequently, which wastes energy, reduces humidity control, and accelerates component wear. Proper sizing based on load calculations, manual JS is essential. Adequate airflow alone cannot mitigate short cycling. Oversizing to compensate for duct issues is inefficient. Duct repairs are preferable. Question 26. In the context of ventilation, what is the most significant risk of reducing outdoor air intake in an attempt to improve energy efficiency during A retrofit: A. Increased energy consumption. B. Reduced indoor air quality leading to occupant discomfort or health issues. C. High mechanical ventilation system noise. D. Increased equipment maintenance frequency. Answer. Correct answer. B. Explanation: reducing outdoor air below code requirements at ASHRAE 62.1 compromises indoor air quality and can cause buildup of pollutants, CO, and moisture. This leads to occupant health problems and discomfort. Energy savings are lost if HVAC suffers, potentially increasing complaints and liability. Question 27. While evaluating a recent new retrofitted system, Mr. Davis notes that measured refrigerant superheat is below specification, but subcooling is within range. What does this indicate about system operation? A. The system is undercharged. B. The expansion valve may be overfeeding refrigerant or malfunctioning. C. The compressor is failing. D. The condenser coil is dirty. Answer. Correct answer. B. Explanation. Low superheat with normal subcooling often indicates the expansion valve is allowing excessive refrigerant, flooding the evaporator and risking compressor damage. Undercharge typically results in high superheat. Compressor failure and dirty condenser affect pressures but not specifically superheat. Question 20. Through careful analysis of the system, Patel finds that the retrofit's new built-in automation system, BAS, is not responding correctly to thermostat inputs. What is the best troubleshooting step? A. Reset the entire BAS controller to factory settings. B. Verify communication wiring and protocols between thermostats and BAS controllers. C. Replace all thermostats with new models. D. Disable BAS controls and revert to manual operation. Answer. Correct answer. B. Explanation. Most BAS issues stem from wiring or communication protocol mismatches. Verifying these avoids unnecessary hardware replacement. Resetting without diagnosis can cause loss of custom programming. Disabling BAS defeats retrofit purpose, but replacing thermostats is premature without root cause. Question 29. When faced with low airflow readings at the supply registers after a duct retrofit, which of the following should be checked first? A. Refrigerant charge. B. Register dampers and obstructions. C. Thermostat calibration. D. Compressor operation. Answer. Correct answer. B. Explanation. Register dampers partially closed or obstructed registers commonly cause low airflow. Refrigerant and compressor issues affect cooling but not directly airflow. Thermostat calibration influences temperature control but not airflow volume. Question 30. Based on the information from the retrofit, why is it critical to ensure proper color coding and labeling of electrical wiring during system installation? A. To enhance aesthetic appearance of the wiring. B. To facilitate troubleshooting, maintenance, and code compliance per NEC. C. To increase electrical conductivity. D. To reduce electrical resistance in circuits. Answer. Correct answer. B. Explanation. Proper color coding and labeling per NEC standards ensure safe maintenance, reduce error risks, and ease troubleshooting. Aesthetic appeal or conductivity are not affected by wire color. This is a key safety and compliance requirement.